to Year 10. In this video I'm going to do the equation solving extended abstract question from the JAF practice test, and I've also put a few other examples in to give you a bit more practice at working with hard linear equations that have got fractions, x's on both sides, and expanding brackets. So we'll start off with this one here, which is the one from the JAF practice. If you haven't already done it, can you please pause the video now and do some good working and have a go at it. Okay, so we look at it before we start. Let's see what we've got. We've got some brackets in the numerator here. Divided by 7 is equal to negative 8 times x minus 3. So where am I going to start? Well, I can undo the divided by 7 by multiplying both sides by 7. So let's do that first. There's nothing to stop you expanding the brackets first. It's just going to be a little bit messier. So now I get negative 56 times x minus 3. Expanding the brackets again gives me 4x, expanding the brackets for the first time gives me 4x minus 8 plus 3 is equal to negative 56x plus 168. Very silly numbers. Okay, so I'm going to collect the x's up here and the constants over here. I'm going to add 56x to both sides. That's going to give me 60x equals 168 plus 8 minus 3. Now, I could have cleaned that up first and made it take away 5. What do we end up with? 60x is equal to 173. And now x is equal to 173 over 60. So just notice that as usual with every step it's getting a little bit easier. And that's my final answer for that one. I'm going to show you how that would go if instead we decided to expand out the brackets first. Okay, so I'm going to do the same question in a different way. I wouldn't usually do it this way, but I think that sometimes when you're learning how to solve harder equation problems, it's good to see that sometimes different ways do still make sense. They're just a little bit slower. So let's expand out here. We've got 4x minus 8 plus 3 over 7 is equal to negative 8x plus 24. And now I'm going to multiply both sides through by 7. I have to treat this as being inside a bracket. Right, so I need to multiply all of this by 7. On the left-hand side, I've got 4x take away 5. And on the right-hand side, I've got this, 7 times negative 8x plus 24. 4x minus 5 gives me negative 56x plus 168. And again, we get 60x is equal to 173. X is equal to 173 divided by 60. Okay, so that's the first one done, and that's the one that's in the practice test. But here are a couple of others that I thought were worth having a look at. And I've made them ones where we've got two different fractions on the left-hand side, and then another fraction here. We've got 3 different denominators. So when we're adding or subtracting fractions, we have to get a common denominator. And the way to do that is to find the lowest common multiple of these. In some cases, that just means timesing the numbers together, and that's going to be the case here. But if I had divided by 3, divided by 6, and divided by 21, the lowest common denominator wouldn't be found by timesing all of those together. The lowest common denominator there would be to make it out of 42. Okay, but in this one here, 7, 5 and 2 have a lowest common multiple of 70. So that's your clue for that one. So pause the video now and try and do that question, and I'll go through it. Okay, so we have this. So I'm using my ideas here of equivalent fractions. Some of you, especially if you have had tutoring that focuses more on just how to do things rather than understanding, might use a different method here. I'm okay with that as long as you understand why it works. But my way is to work first with the equivalent fractions idea. So what do I have to do to that 7 to get 70? I'm multiplying by 10. So I have to do the same thing to this. Right, what did I do to the 5 to get to 70? I times it by 14. So here I'm going to have take away 28 times x minus 5. What did I do to the 2 to get 70? I multiplied it by 35. So now I've got 3 fractions. It doesn't look very good. But remember, as long as we do the same thing to both sides of the equation, nothing can go wrong. So I'm going to multiply everything through by 70. And when I do that, I'm left with a much simpler looking equation, which is this one here. So now all I need to do is to expand the brackets and collect up like terms. 28 times 5 is 140. Just notice that it's a minus takeaway times a takeaway, so it's a positive. And we've got 35x here. So cleaning that up gives me 12x plus 100 is equal to 35x. Subtracting this from both sides gives me 100 equals 23x, or x is equal to 100 divided by 23. Okay, I'm going to do that one a different way as well. So let's go back to the question. So what I did the first time is I got a common denominator with everything. I looked at this, the 7 and the 5, and I also looked at the 2, and we found the lowest common multiple was 70. The other approach I can take is to just think about combining these two first. So that would give me a lowest common multiple of 35. What do I have to do to the 7 to get to 35? I times by 5. So that's what I have to do to this. That gives me 20 times x minus 1. What do I have to do to the 5 to get to 35? Multiply it by 7. So now I need to have take away 14 x minus 5. And now I've got just x over 2 here. I'm going to clean up the numerator by expanding the brackets. I'll get 20x minus 20 minus 14x plus 70 divided by 35 is equal to x over 2, giving me 6x plus 50 over 35 equals x over 2. I can multiply both sides by 35 and both sides by 2. That means I'm going to have here 2 times 6x plus 50 is equal to 35x. Now often you'll hear people talk about the idea of cross multiplying, and this is what they mean. And I really don't like that term unless you really understand why we're doing it, right? And it's because we're multiplying both sides by the same thing. Because if I put in a times, oops, that's gone away, not meant to happen. If I times this whole thing by 35, these go. And now if I times both sides by 2, the same thing's going to happen. So let's multiply both sides by 2. I get times 2 here, and I get times 2 here. So that's how I end up with 35x over here, and 2 times this here. Okay, but I never teach it with this crisscross diagram, because I don't think students always understand it if we do it like that. So we get 12x plus 100 is equal to 35x. That gives me 100 equals 23x, and x is 100 over 23. Right, I've got 5 minutes left. I'm not sure if anyone is still watching, but I want to do one more tricky equation. Let's go all the way back to the top. Okay, this one here. So here we've only got one with a fraction, but the common denominator idea is still what I'm after. So I want you to think about putting in the denominator here and here. I'm going to add a new page and do it there. So we start off with this. So I'm going to get a common denominator of 3. So here I'll have 18 times x plus 5 over 3, and here I'll have negative 9 times 2 minus x over 3. Multiplying everything through by 3 gives me this. And the obvious next step now is to expand out these brackets and then collect up my like terms. Right, what have I got on the left-hand side? Negative 16x, take away 100, equals negative 18 plus 9x. I'm going to bring the 16x to the right-hand side by adding it to both sides. And I'm going to bring the negative 18 to both sides by adding it to the left-hand side. So we get 18, take away 100, equals 9x plus 16x. That gives me negative 82 is equal to 25x. Not very nice numbers in this video. X is equal to negative 82 over 25. So there you go. Leave me a comment if you've got any questions on similar kind of tricky linear equations. And I'm going to do a video soon on inequations. But there'll be easier problems to solve. Thanks for watching and have a good weekend.